Welcome to this NPTEL course on Dynamics and Control of Mechanical Systems. My name is Ashitava Ghosal. I am a professor in the Department of Mechanical Engineering and also in the Center for Product Design and Manufacturing and the Robert Bosch Center for Cyber Physical System, ISC Bangalore. Mechanical engineering contains many sub-disciplines. So for example, you can have thermal systems, fluid mechanics, solid mechanics, materials, design, manufacturing. In this course, we will look at mechanical systems. Mechanical systems in its own has areas on mechanisms, actuators, sensors, and computers. So for example, this picture shows a gripper used in a robot. This has a 4-bar mechanism. In this picture shows a servo-controlled DC servo motor. And this is a very well-known actuator which is used in many mechanical systems. In mechanical system, you will also have sensors. So for example, this picture shows an optical encoder which can be used to measure the rotations of the motor shaft. And finally, we have computers which are used extensively in many mechanical systems now, which can be used for data processing and control and various other operations. Mechanical systems in this course, we will look at 3 main topics. So we will look at kinematics, we will look at dynamics, we will look at controls. So in kinematics, we have this something called particle kinematics, where we look at the point mass. Then we have rigid body kinematics, and then single rigid body can be connected by joints to make up a multi-body system, and we will look at the kinematics of multi-body systems. And then we also have dynamics. So in order to study or look at dynamics, we first need to study kinematics. The main goal in dynamics is to derive what are called as equations of motion. In kinematics, we do not look at the forces and moments and external torques which are acting on the system, but in dynamics, we will look at how the system behaves when external forces and moments act on the system. The next logical step is to control the mechanical system. A normal mechanical system, when you apply a force or a moment, it will have its natural dynamics. But we would like to make sure that the mechanical system follows a desired trajectory. Okay, and that is the topic of control. There are 2 main ways of doing control. One is classical methods, which we will look at later on in this course, and state space method. Okay, so here are 3 videos which I am going to show you where both kinematics and dynamics and also control are very useful. So the first one is a robot which is called a sun tracking device. So basically what you can see is that there are 2 mirrors which are used to track the sun and then focus the incident beam onto this so-called receiver. Okay. These 2 pictures at the bottom, which you show the video, they are a 4-legged quadruped which we were building. And each one of these legs of this quadruped is shown here, how it behaves. It is basically a 2 degree of freedom system. So once we study kinematics, dynamics, and control, we will be able to study, analyze, and design such mechanical systems. The scope of this course, as I have mentioned earlier, is on kinematics, dynamics, and control. So the first half, a little bit more than the half, for the first 7 weeks, we will look at kinematics and dynamics. So first week is mathematical representation and position and orientation of a rigid body, then velocities, then we look at a system of rigid bodies, then we will look at mass inertia of a rigid body, then we will look at what are called as Newton-Euler formulations and Lagrangian formulations to derive equations of motion. Okay, and then we will look at on week 7 how we can use this modeling and simulation of multi-body systems and how we can simulate them and how we can do them using computer tools. In week 8, we will look at these equations of motion and how we can linearize the equations of motion and how it naturally leads to the state space formulation. Okay, and then we will look at the solution of these state equations. In week 9, 10, and 11, we will look at control of these mechanical systems. And finally, in week 12, we will look at some examples and case studies of control of mechanical systems. So the expected outcome of this course are the following. So after successful completion, a student will be able to mathematically represent a rigid body or a system of rigid bodies in 3D space. Okay, and we will represent them in a form which is amenable for analysis. Then a student should be able to obtain and analyze the kinematics of a rigid body or a system of rigid bodies. The student should be able to obtain the dynamic equations of motion of a rigid body or a multiple rigid body system using Newton-Euler and Lagrangian formulation. So we will look at these different formulations. The student should also be able to numerically solve equations of motion using computer tools. A student at the end of the course should be able to obtain and understand the state space representation of linear systems, understand the concept of stability, controllability, and observability of linear systems, and design of controllers using state space and classical control methods. The prerequisites for the course are knowledge of mechanics at the undergraduate level, so notion of position, velocity, acceleration, forces and moments, Newton's law, and concept of energy. A student should also have a basic knowledge of linear algebra, vectors, matrices, eigenvalues, and eigenvectors. He should have a basic knowledge of undergraduate calculus. Derivative of scalars and vectors will be used and assumed to be known by the student. And a familiarity and knowledge of programming with any language, but MATLAB is preferred. And also MATLAB is available for use by NPTEL participants. A video on the overview and use of MATLAB for this course is available. Okay, it has been created by Mr. Soumyakanti Mahapatra, a PhD student in the Robotics and Design Lab, ME Department, IISc Bangalore, and he will also be the TA. So there will be many instances where MATLAB will be useful. So it is a good idea to get familiar with MATLAB. The 4 main textbook and references for this course are, there is a book called Engineering Mechanics, Dynamics, Volume 2. It is by Merriam and Craig. Then there is a very old book called Spacecraft Dynamics by Kane, Likens, and Levinson. And for control, it's a good idea to refer to this Modern Control Engineering by Ogata. And then there is another book called Feedback Control of Dynamical Systems by Franklin, Powell, and Imami Naini. The contact details for this course are the following. So I am Ashitava Ghosal. This is my email ID. And the TA for this course is Soumyakanti Mahapatra. This is his email ID. And queries regarding the course material and assignments will be addressed by a forum, which will be set up by NPTEL.